let's talk about solving linear inequalities. Before we get started, I want to run through some quick definitions. The symbol I have at the top of the screen is our less than symbol. We can use this in the following type of statement. X is less than 3. That means our values of x are going to be smaller than the number 3. Visually on the number line, we can shade in this region by coloring in everything that is to the left or smaller than 3. If we have a less than symbol or a greater than symbol, we can actually use a parenthesis right here at 3 to indicate that 3 is not part of our solution. Our solution is only numbers that are smaller than 3. Another way we can denote this is we can put an open circle at 3, so a circle that's not shaded in. And again, that indicates that 3 is actually not part of the solution. The x values are only numbers that are smaller than 3. The next symbol is our greater than symbol. We can use that symbol in a statement like x is greater than 2. That means our x values are larger than the number 2. On the number line, we would shade in everything to the right of the number 2. And once again, I'm going to use a parenthesis to indicate that 2 is actually not part of the solution. Our x's are only numbers that are bigger than 2. We could also use an open circle to indicate the exact same thing. X is bigger than 2, but not actually including 2. When creating number lines from inequalities, I like to remember that the direction you shade in points in the same direction as the inequality. So if you kind of think of this inequality as like an arrow, that's telling you which way to shade in. So we're going to go to the right because it's a greater than symbol. All right, 2 more symbols. The following is our less than or equal to symbol. So I could say something like x is less than or equal to negative 2. That's going to be all values that are smaller than negative 2. But because we have that little line, that indicates that we could also be equal to negative 2. And so we can denote that by putting a square bracket in at negative 2. We could also use a closed circle, a colored in circle, instead of the square bracket. And that indicates that negative 2 is part of our solution set, as well as everything that is smaller than negative 2. Finally, our last symbol is the greater than or equal to symbol. So I could say something like x is greater than or equal to 2.5. On the number line, that is everything that is bigger than or to the right of 2.5. Because we have that or equal to symbol, we're going to use the square bracket, or we can use a closed circle. And again, that just means that 2.5 is part of that solution, as well as everything that's larger than it. All right, so now let's solve some inequalities. And the directions actually say solve and graph your solution on a number line. So we're going to start with the problem 2x minus 7 less than or equal to 3. It turns out when we're solving linear inequalities, we can use a strategy that is nearly identical to what we did when we solved linear equations. We're allowed to add the same number to both sides, subtract the same number, multiply, divide. Whatever we do to one side of the inequality, we have to do to the other side. We're going to learn that there's really only one kind of small difference, and we'll see that in our next example. But let's just start with this problem. 2x minus 7 less than or equal to 3. So I'm trying to isolate the x, so I have to get rid of the minus 7. I'm going to do that by adding 7 to both sides. Now I'm left with 2x less than or equal to 10. 3 plus 7 gives us 10. Finally, if we want to get the x by itself, we have to get rid of that 2. It's 2 times x, so I'm going to divide both sides by 2. And that gives me x less than or equal to 5. 10 divided by 2 is 5. One thing to notice as I'm working through this problem, my inequality symbol stayed the same throughout the whole problem. I started with a less than or equal to symbol, and I'm ending with a less than or equal to symbol. Turns out that there's going to be only one case where that inequality symbol changes, and again, we'll see that in our next example. All right, finally, we need to graph this solution on the number line. So I'm going to create a number line with the number 5, less than or equal to. The or equal means I need that closed circle, less than, shade to the left. So my answer is any number that is smaller than 5, including 5 as well. All right, here's my second example. Negative 3x plus 5 is less than 10. So let's start this problem the same way we did the previous problem. I want to get rid of that plus 5 so that I can isolate that term with the x. To do that, I'll subtract 5 from both sides, and that gives me negative 3x less than 5. 10 minus 5 is 5. Now, if we want to get the x by itself, we have to get rid of the negative 3. That means we're going to have to divide both sides by negative 3. Now, here's where inequalities are different than equations, or at least in terms of the solving part. If you multiply or divide an inequality by a negative number, it changes the direction of the inequality. So anytime you have to take an inequality and divide both sides by a negative number, or multiply, that's going to change the direction of the inequality. And let me try to explain that with a specific example. So if we have this statement, 2 is less than 3. That's a true statement. That's saying 2 is smaller than 3, and we know that that is correct. But notice, if I change the sign of these numbers, negative 2 less than negative 3, my statement is no longer true. Negative 2 is actually bigger than negative 3. Negative 3 is the smaller number. When we make these numbers negative, it changes which one is smaller than the other. So to make the second statement true, I have to flip the direction of the inequality. Negative 2 is bigger than negative 3. That is now a true statement. All right, so let's go back to the problem we're trying to solve. To get x by itself, we're going to divide both sides by negative 3. Because we're dividing by a negative, that's changing the sign of everything. So we're going to take our inequality sign and we're going to flip it. That's going to give me x, and the less than flips to a bigger than. So x is bigger than negative 5/3. And that's it. That's my answer. I'm going to put that on the number line. To help me graph this fraction, I'm going to change it into a mixed number. 3 goes into 5 one time with 2 left over, so negative 1 2/3. And so then I'll just estimate negative 1 2/3, somewhere between negative 1 and 2. And let's see, it's a greater than, so I'm going to shade into the right, and I'll do an open circle. Here's another example. 5x minus 6 greater than or equal to x minus 14. We want the x's by itself on one side of the inequality. We need the constants on the other side. So I'm going to put the variables on the left side and the constants on the right side. So first thing I'm going to do is I want to get rid of the minus 6 on the left. So I'm going to add 6 to both sides. That gives me 5x greater than or equal to x minus 8. If I want to put the x's on the left side, I have to get rid of this 1x on the right side, so I'm going to minus 1x from both sides. 5x minus 1x is 4x, and so now I have 4x bigger than or equal to negative 8. Finally, to solve for x, we have to divide both sides by 4. Now notice this time I'm dividing by a positive number. If you divide by a positive number, positive 4 in this case, that does not change the direction of the inequality. And so my answer is x is bigger than or equal to negative 2. Again, it's only when you multiply or divide by a negative number that that direction of the inequality flips. So on my number line, greater than or equal to, so I need a closed circle at -2, and then bigger than is to the right. All right, here's my next example. This one's going to require a little bit more simplification. We've got 2 times the quantity x minus 3, then -5, less than or equal to 3 times the quantity x plus 2, then -18. So just like when we were working with equations, first thing I'm going to do is distribute. Get rid of those parentheses. So I'm going to take 2 times x minus 3. That gives me 2x minus 6. And we still have the -5, less than or equal to. And then I'll distribute the 3 to the x plus 2. So that turns into 3x plus 6 minus 18. Now I'm going to combine like terms. So on the left side, I'm going to take -6 minus 5, and that gives me -11. On the right side, I can combine the +6 and the -18 to get -12. So I'm now left with the inequality 2x minus 11 less than or equal to 3x minus 12. I'm going to put the x's on the left and the constants on the right. So that means we have to add 11 to both sides. Now we're left with 2x less than or equal to 3x minus 1. If we want the x's on the left, I'm going to minus 3x from both sides. 2x minus 3x is -1x, less than or equal to -1. Finally, to get x by itself, this -x is technically a -1x, so I'm going to divide both sides by -1. Because I'm dividing by a negative now, that is going to flip the direction of the inequality. And so that gives me x, inequality flips to bigger than or equal to, and then +1. So x is bigger than or equal to +1. So on the number line, I'll put a closed circle at +1 and shade to the right. Now, we can also solve inequalities that have fractions in them, and we can use the same strategy we learned when working with equations, which was clearing the fractions by multiplying everything by the least common denominator. And so that's the technique I want to show you. So I've got the inequality 1/2 x minus 3 bigger than 3/4. We can solve this inequality as is by adding 3 to both sides. However, I do want to really reinforce this idea of clearing fractions by multiplying by the LCD, because that is a strategy that might come up in some future math classes you take. So in this case, the LCD is 4. I have denominators of 2 and 4 is divisible by both 4 and 2. So I'm going to multiply every single term by 4. That means I have to take 4 times 1/2 x minus 4 times 3 bigger than 4 times 3/4. 4 times 1/2 x, so 4 divided by 2 is 2, so we're just left with 2x, minus 4 times 3 is 12, bigger than, last term the 4's cancel out and we're just left with 3. So 2x minus 12 is bigger than 3. To solve for x, we're going to add 12 to both sides. So 2x is bigger than 15. Finally, divide by 2. X is bigger than 15/2. I'm going to convert that into a mixed number to put that on the number line. 15/2, let's see, 2 goes into 15 7 times with 1 left over. So that's 7.5. So I'm going to have to do an open circle at 7.5. And then bigger than means shade into the right. All right, let's run through one more with fractions. Here's my last example. We're going to solve 2/3 times x minus 4 less than or equal to 1/6 x plus 1. So the first thing I'm going to do here is distribute the 2/3 to the x minus 4. So I'm going to take 2/3 times x, that's 2/3 x. Now I'm going to take 2/3 and distribute that to the minus 4. So 2/3 times 4 over 1, we multiply straight across, that gives me 8/3. Okay, so 2/3 times x is 2/3 x, 2/3 times the minus 4 is minus 8/3. Less than or equal to 1/6 x plus 1. Now I'm going to use the same strategy. I'm going to multiply everything by the least common denominator and try to clear the fractions. I have denominators of 3 and 6, so my LCD is 6. 6 is divisible by both 3 and 6. So I'm going to take 6 times 2/3 x minus 6 times 8/3 less than or equal to 6 times 1/6 x plus 6 times 1. To make sure I multiply every single term by 6. First term, 6 divided by 3 is 2. 2 times 2 is 4, so that becomes 4x. Second term, 6 divided by 3 is 2. 2 times 8 is 16. Less than or equal to. Next term, the 6's cancel, and we're just left with 1x. Finally, 6 times 1 is 6. So now I have the inequality 4x minus 16 less than or equal to x plus 6. We can solve this by putting the constants on one side. So same inequality, I just made a little bit more room on my screen. So I want to put the constants on the right, so I'm going to add 16 to both sides. That gives me 4x less than or equal to x plus 22. If I want the x's on the left, I'm going to minus 1x from both sides. 4x minus 1x is 3x, less than or equal to 22. Finally, divide both sides by 3. X is less than or equal to 22/3. Notice I divided by a positive number, so the direction of the inequality didn't change. And that's my answer. To finish, I'm going to put that on the number line. I'm going to convert 22/3 into a mixed number. 3 goes into 22 7 times, with 1 left over, so 7 1/3. Finally, I'm going to put a closed circle at 7 1/3. I have to kind of estimate where that is. And then it's less than or equal to, so I shade to the left, again with that closed circle. All right, that was my last example in this video. As always, please reach out if anything is unclear.